Hi, this is Rob Shore, Director of Global Technical Sales for Coriant. In this video, what I want to take a look at is a variety of different optical layer solutions for transport networks and some of the specific innovative solutions that Coriant has developed to make deploying these networks easier and more operationally friendly with more scalability. Before we get into that, what I want to do is understand a little bit about transport networks in general. For transport networks, there's two distinct layers. There's an optical layer of the transport network that has a bunch of different types of solutions, each with different pluses and minuses. And there's an electrical layer of the network that each also has its own set of pluses and minuses, right? So the electrical layer, how it handles services from OTN or SDH or packet, and optical from fixed optical all the way to ROADM with colorless, directionless, contentionless. So I've got these two distinct separate parts of the network. And one of the things that's important to understand about transport networks is you really can choose these two different solutions completely independently from one another. What I do on the electrical side of the network is completely independent from what I do on the optical side, and vice versa, right? So when I pick the optical network, it's in no way going to limit me what I can do on the electrical side. For this video, what I am going to focus on specifically is the optical layer solutions and some of the different things that we can do in the optical layer, and specifically some of Coriant's innovative solutions on the optical layer. One important thing to know is when building an optical layer network, network operators are typically faced with this very early decision, right? This decision of which way to go and how to build that network. On the left side of the network here, you have the ROADM-based solutions, these very low-cost, fixed optical, often very manually intensive, and not very scalable solutions. But again, they're very, very low cost, so when they first start building a network, a lot of times operators choose this solution not knowing where their network is necessarily going to go. On the other side, on the right side of this fork, you have these very automated solutions, these ROADM-based solutions that are much more scalable, much more operationally efficient, but they're also much more expensive. So network operators are often forced to make this decision very early on as they're building and deciding how to build their networks. And one of the big challenges associated with this is this big gap between the functionality provided by these two solutions. There's a very large gap between what each of these two types of solutions can provide, right? As I mentioned, these ROADM solutions are very low cost, but they don't provide a great deal of scalability or automation in the network, as opposed to ROADMs, which are much more expensive up front, but do provide additional scalability and automation. And another big problem with these types of solutions, traditional solutions, is that if I choose to go the ROADM route because I don't know where my network is going to go, or I don't want to spend all that money up front, it's very, very difficult to go from the ROADM, this manually intensive-based solution, to ROADM-based solutions to get some of those features. There's very few ways to upgrade that type of network. So as Coriant has developed our optical layer solutions, these are some of the challenges that network operators face that we're looking to overcome. So one of the key things that we've done here is we focus starting off on the ROADM side of things, right? And what we're trying to do here is optimize ROADM-based solutions. We're trying to make these easier to deploy and more cost-effective so I can extend the reach of full-blown ROADM-based solutions deeper into the network, deeper into the metro network. On top of that, at the edge of the network where I still can't fully justify a full-blown ROADM, what we're trying to do is make some of the functionality of the ROADMs available to the edge of the network without having to buy the full-blown ROADM and all the aspects and costs associated with that. So as we go through our solutions, we're going to start off by taking a look at what we've done on the ROADM side to make that more cost-effective and easier to deploy. And if we look at some of the benefits that a ROADM provides, right, ROADMs provide all kinds of interesting benefits for a network. In some of my other videos, I've talked extensively about Optical Express and all the economic, operational, and reliability benefits Optical Express provides. But ROADMs also provide a variety of other benefits to the network as well, including power monitoring, per-channel power balancing, in-band management, wavelength switching. So ROADMs provide all of these really, really powerful benefits to a network. But in order to achieve these benefits, ROADMs require a lot of different pieces of technology, right? Everything from a variety of types of amplification, preamplification, booster amplification, power monitoring, power balancing, wavelength switching, in-band management. There's all of these different functions required to achieve that full set of benefits that ROADMs provide. So one of the things Coriant has done is, unlike traditional solutions that take a lot of these different functionalities and build them onto separate full-size modules that you have to buy independently and install independently and then have to cable together, what we've done is taken all of these functions associated with a full-blown ROADM degree and we've integrated them onto a single interface module. Every function now built directly onto one card. You can buy one card, physically install one card, not have to cable between them at all. And on top of that, this is a single slot module as well. So what we've accomplished here is not only reducing the cost of the ROADM solution by integrating everything into a single card, we've also created the industry's most compact multi-degree ROADM-based solution, and actually by a pretty good clip. But ROADM solutions aren't just about the card itself. This certainly has made ROADM technology easier to access with the density and cost effectiveness of it, but it's also how that integrates into the overall network solution. And you can see how that integrates into our 7100 packet optical transport platform. This is the nano shelf of the 7100, which is a 6-slot shelf. And what we now have is a single slot module that can be placed into any and all slots on the 7100. I now can have a full 6 degrees of ROADM solution on a single 5RU shelf. Now, the system's capable of up to 8 degrees, but I can put 6 degrees on one shelf. So again, not only does the card itself provide a very compact and cost-effective solution, but when used in conjunction with the 7100 Nano system, you have an overall solution that's extremely compact and cost-effective. So again, the idea of building the ROADM this way and focusing on optimizing the ROADM, what it's enabled me to do, and enables network operators to do, is take ROADM-based functionality, not just in the core networks and the metro core, but really extend that closer and closer to the edge of a metro network. Now, having said that, there are still places in a metro network that are not big enough to justify a full-blown ROADM. Right? ROADMs are still good for mesh networks and high-capacity networks, but you have these areas in the edge of the network that you just can't justify and don't need all of the different functionalities associated with a ROADM. Like if I only have a ring, I certainly don't need multi-degree switching. So what we've really tried to do is focus on coming up with a solution that enables access to all of these different ROADM-based functionalities without having to buy all of them all at once. And what we've done is come up with this very innovative solution that we call the Coriant Pluggable Optical Layer. And what the Pluggable Optical Layer does is take each and every one of these functions from a full-blown ROADM solution and extracts them onto these small, discrete form factor, pluggable components. Pluggable components, by the way, that includes XFPs and SFPs, industry standard pluggable form factors, but also some new form factors here we call OFP1s and OFP2s. Now, these are based to a large extent on other industry standard form factors, such as the OFP2 is very similar in size and form factor to a CFP2. But what we've done is just optimized it to make it more cost effective for optical layer functionality. For example, I'm not transmitting 100 gig worth of traffic across a backplane, so I can have a much more cost effective connector on an OFP2. But is by and large the same size and shape of a traditional CFP2. And again, you can build all kinds of different optical layer functionality onto these components. In fact, the OFP2 in particular has a huge number of different functions I can build on there. One, of course, is this optical amplification. You do optical power monitoring as well. And in fact, not only can I build optical amplification, I can actually put multiple amplifiers on a single OFP2. This enables me to do things like dual preamps, so I can actually have a single component that amplifies east and west directions in a network. I can do a preamp and a booster amp for longer distances, and I can also build on all kinds of automation functionality as well, whether it's power monitoring or automatic gain control, transient control, all kinds of interesting things that you can build on the OFP2s. Now, for more advanced network functions, such as wavelength selective switching, for that you have to go to the OFP1 size form factor. OFP1s are a bit bigger than a traditional CFP, but these are only really necessary for those most advanced network functions like wavelength selective switching. But the idea behind this now, by building these functions discretely into these very small form factors, compact and cost-effective, pluggable components, it enables network operators now to pick and choose exactly the functions that they want in their network without sacrificing, right? Still having access to all of the functionality that a ROADM provides, but picking and choosing only the functions that they want and just plugging those in very easily into the network. Now, instead of building these integrated comprehensive cards, I can build these optical carrier cards, right? And these are basically just a piece of silicon, connections to the backplane for power and monitoring. But fundamentally, these are just pieces of silicon that have ports on them, ports in which I can plug in my pluggable optical components. So again, I can pick and choose exactly the functionality I want and just slot those in into these pluggable ports and get exactly the functionality in the network that I want. Additionally, as I want to expand my network, either scalability or add additional operational features, I can just pick additional pluggable optical components that have the functionality I want and just slide them right in. So the idea now is I don't need, at the edge of my network, I don't need to buy these comprehensive cards, these comprehensive ROADM-based solutions to get access to some of these functions. I can pick and choose exactly what I want. On top of that, I can build these carrier cards. I can actually tailor them with different sets of port counts. And the idea of these being pluggable components themselves now, just like XFPs and SFPs, they become non-system specific, right? These are now standardized form factors for which I can build carrier cards that plug into any system. So I can now carry the same set of functionality and flexibility to any system by building a carrier card with the appropriate combination of ports. So again, what you have here now is a solution that puts all of the power in the operator's hands to pick and choose exactly which functions they want, not having to buy any functions that they don't need, but not being limited to the functions that they want. And on top of that, giving the opportunity to expand the functionality of the network very simply by just grabbing the right components you want and just plugging into these little pluggable components, all on a solution that is not system specific. So if I look at this from an application perspective, right? Of course, you can do simple point-to-point based applications. I can do small ring applications, even with Optical Express. And any amplification required in this network can all be accomplished primarily by these OFP2s. And the idea now is these OFP2s can come in a variety of different, or do come in a variety of different forms and functions, right? So I can have short reach, long reach, I can have dual amplifiers, I can have all kinds of different operational functions integrated into the amplifiers. So on a point-to-point perspective, right, you can get amplifiers in these OFP2 form factors that on a point-to-point perspective can enable you to go up to 160 kilometers with a limited channel count, or with a full channel count, I can go a full 120 kilometers on point-to-point. For these ring applications, now I'm more interested in how many nodes I can express through, right? I'm really concerned about the end-to-end distance without regeneration. And based on the way these optical components are engineered, along with the add and drop filter components of the pluggable optical layer, I can actually traverse up to 6 nodes with 60-kilometer spans, right? So essentially, I can go 360 kilometers from one end of the network to the other end of the network without any per-channel power balancing with just these little OFP2s. So again, you've got this extremely cost-effective solution, extremely compact solution that can really enable a variety of different types of network architectures and functionality. When I look at how these actually integrate into our systems themselves, on a nano, let's say I've got this hub node over here and I've got a 7100 nano. For that, I can buy this carrier card that has multiple OFP2 ports on them, right? And with these dual amplifiers, I can actually do the east and west optics on a single OFP2. So really, with a single optical carrier card, I can actually have multiple rings or multiple spurs or a combination of rings and spurs hanging off of that node. When I get more towards the edge of the network to these smaller locations, maybe I move to the 7100 Pico. And the Pico has an interesting characteristic to it that I have this auxiliary slot in the Pico, this little tiny auxiliary slot in the upper left-hand corner. That can also house OFP2s. What that enables me to do now, especially with this dual preamp version of the OFP2, right, that I'm doing east and west optics in a single OFP2 that both plug into this auxiliary slot, is I can now sit the Pico on a ring with east and west amplification without consuming any of the interface slots, right? Both interface slots can still be used now to provide services. So again, what you end up here with is a solution that's immensely compact, cost-effective, and flexible, and simple to pick and choose the features you want and add features as your network grows, and essentially provides really the perfectly customizable network solution, particularly for the edge of a network. Right. Now again, let's not lose track of the fact that if you do want all of the functions of a full-blown ROADM, you're still best off buying that fully integrated card, and that's still the best solution for more dense and meshy metro core networks. But as I get to these smaller networks, sort of the metro edge of the network, right, the pluggable optical layer becomes an extremely powerful solution to get exactly the functionality that you want. Now this network diagram actually just looks at these standalone applications where I'm building a single ring or a single point-to-point application. The pluggable optical layer also has another powerful implementation or application where I can use it to extend the reach of a ROADM-based network. So if I have a dense metro ROADM core, and I want to extend some of these ROADM-like functionalities to the edge of my network, but I don't want to buy the full-blown ROADM, I can actually have a single system here now, and you're seeing a 7100 nano, where I've got ROADM cards connecting to my ROADM-based network, and I've got that pluggable optical carrier card now extending to the edge of the network, housing the pluggable optical components. All right? So not only can I integrate this onto a single system where I've got the two networks coming together, the ROADM-based network and the pluggable optical layer-based network, but the optical layers themselves are actually meshed together. right? Essentially what I can now do is launch a signal all the way at the edge of my network, and I can express that all the way through even this hybrid node where the signal goes all the way through purely optically. So again, I'm extending the reach and power of these optical express-based functionalities right now with a ROADM-based optimized solution, and then interwoven with a pluggable optical layer-based solution, really providing an extremely powerful overall end-to-end network solution. And by the way, this interworking here between the pluggable optical layer and the ROADM-based layer and the ability to express a service between them, that's a function and feature we call Spur Express. And it's a unique function provided by Coriant's optical layer solutions and the way we interwork our pluggable optical layer with the ROADM-based layer. So in a whole here, what we've done here at Coriant in developing our optical layer solutions is really two key things. First, we focused on the ROADM side of the network, right? And as network operators go to build their networks, we've focused on building the ROADM and making it more efficient, more compact, more cost-effective to enable access to that functionality deeper into the metro network. So we've broadened the reach of accessibility to ROADM-based functionality. But at the same time, we've attacked the lower end of the network by enabling very, very low-end solutions. But using the pluggable optical layer, you now have access to everything up until a full-blown multi-degree ROADM and these small, compact, pluggable components. So essentially what you have here from Coriant now is a complete end-to-end solution where you can get exactly the functionality you want. You can make your network as cost optimized and as operationally optimized as possible. And even if you start at the very low end of the solution, you still have access to any other feature you want to either deploy or upgrade your network. So you've got now this complete end-to-end networking solution for any optical layer needs and operational needs that you need in your network. This comes to the end of the presentation. If you have any other questions about more details about Coriant's pluggable optical layer, our ROADM-based solutions, or any other Coriant-based solutions or technologies, please come and visit us at Coriant.com. That comes to the end of the video. I hope you enjoyed it, and thanks for watching.